More than 1 million miles from Earth, an eye unlike any other peers silently into the abyss. The James Webb Space Telescope, heralded as the most powerful observational tool humanity has ever built, has been sending back images so stunning, so revealing, and so precise that they threaten to rewrite everything we thought we knew about the cosmos. But here's the part that no one's talking about. Not everything it sees is being shared with the public. Some of its most haunting discoveries are buried in technical papers or quietly omitted from press briefings. And as you're about to see, the latest round of pictures supposedly just snapshots of galaxies, stars, and nebulae may actually contain something far more complex, more structured, and more deliberate. Because buried within the beauty of these images, something doesn't quite add up. Something looks designed. And if that's the case, then what exactly is the universe trying to show us? And why are scientists so reluctant to explain? In September, JWST delivered what appeared to be a lighthearted cosmic phenomenon. Two galaxies colliding, known as ARP 107, forming a structure that oddly resembled a smiling face. To the untrained eye, it was a curious coincidence, but to astronomers, it was deeply unsettling. Why? Because the shape, symmetry, and alignment of the galaxies, and more specifically, the bridge of stars connecting them, wasn't just poetic. It was unnatural. These weren't chaotic galaxies crashing in random motion. The spiral and elliptical galaxies involved had maintained structure in a way that defies gravitational modeling. Even more bizarre, the spiral arms had almost completely vanished, yet the nuclei remained undisturbed, something that shouldn't happen in typical galactic collisions. At the center of ARP 107 is a safer galaxy powered by a supermassive black hole emitting far more energy than expected. JWST's near and mid-infrared cameras revealed not chaos, but balance, almost a precision in how these galaxies interacted, like choreography. And as researchers dug deeper, one quiet question kept resurfacing. What if this wasn't just a collision? What if it was a demonstration? Earlier in the year, JWST turned its attention to a mysterious stellar nursery known as N79, located in the Webb Large Magellanic Cloud. On paper, it was just another star-forming region until the images came in. The nebula's central light source glared so intensely it distorted JWST's optics. An hourglass-shaped shadow emerged, cast by jets of gas from a young star. But the jets themselves behaved unusually. Instead of random orientations, they were aligned, flowing in the same direction with an eerie synchronicity, suggesting a unified rotational momentum across the entire star field. This kind of order in such a turbulent region was unprecedented. Scientists called it a cosmic memory, a leftover trace of how the original cloud spun before stars were born. But that raised another, more disturbing possibility. What if this wasn't a memory, but a signal? The consistency of these jets has no logical reason to persist over such a large region unless governed by an external, perhaps, geometric influence. The deeper JWST looks, the more it finds evidence not of randomness, but of pattern. And patterns beg the question, who or what is doing the arranging? WP39b, a gas giant orbiting 700 light-years from Earth, had already puzzled scientists for years. But when JWST aimed its infrared sensors at this tidally locked world, where one side always faces the sun while the other is frozen in perpetual night, the data that returned was not just strange, it was mathematically perfect. The twilight zone, where day turns to night, exhibited a consistent temperature gradient that defied known atmospheric models. But it wasn't just the heat distribution, it was the cloud behavior. The side facing sunrise was denser with clouds. Clouds made of condensed gases like sulfur dioxide and water vapor. while the evening side was almost entirely clear, as if something was orchestrating a reset cycle at the same rotational interval. Even the wind patterns behaved in a way that appeared engineered. The data suggested that heat transfer across the planet was too efficient, like the atmosphere itself had been designed to balance extremes. The planet was dubbed inhospitable, yet it taught us something vital. Nature, under the lens of JWST, often behaves less like a storm and more like a system. And systems have structure, logic, boundaries, even purpose. In July, JWST captured what might be the most haunting image of the year. Against the swirling chaos of a star-forming region stood a bright red symbol, a perfect question mark. To most viewers, it was a whimsical oddity, but scientists knew better. Located within the Herbig-Haro 4647's complex, the structure was too detailed to dismiss. Theories flooded in: merging galaxies, gravitational lensing, overlapping star systems. But none could explain the shape's perfection. And more disturbing than the question mark itself was where it was found. Among the earliest forming galaxies in the known universe, structures emerging just 400 to 600 million years after the Big Bang. These galaxies showed signs of gas streams, being shaped not only by gravity, but by radiation jets from their central black holes, jets forming lines, arcs, even filaments, as if painting on the canvas of early space. And now, JWST's highest resolution images reveal these alignments are not random. In multiple systems, black hole jets appear to orient in parallel. If true, then the question mark isn't a symbol of confusion. It's a symbol of something bigger, something deliberate. And the real question isn't what is it. It's why is it there? It's why is it there? When James Webb peered into the cosmic dawn, the era just after the Big Bang, what it found defied not just expectations, but the very foundation of cosmology. Galaxies forming just 400 to 600 million years after the birth of the universe should have been chaotic, clumpy, irregular clouds of gas. But JWST revealed something else entirely: massive, mature-looking galaxies with rotational symmetry, dense star populations, and most disturbingly clear evidence of structure. According to every model we've ever built, these galaxies shouldn't exist yet. They're too big, too organized, and too evolved. And the deeper JWST looks, the more of them it finds. Scientists initially thought they'd made an error: redshift miscalculations, data artifacts. But the consistency of the observations forced a terrifying possibility. Our timeline is wrong. Either the Big Bang happened much earlier than we thought, or galaxy formation doesn't obey the rules we've believed for nearly a century. And if these galaxies are real, mature, and aligned in ways we can't explain, then someone or something started organizing the universe much earlier than we were supposed to notice. Most people think brown dwarfs are the silent failures of star formation, too big to be planets, too small to shine. But JWST revealed they're anything but silent. In a pair of nearby brown dwarfs, WISE 1049a and WISE 1049b, the telescope detected turbulent, towering storms in skies filled with hot silicate clouds, essentially vaporized sand suspended in atmospheres of chaos. These failed stars rotate so rapidly, completing full spins in just 5 to 7 hours, that their atmospheric layers ripple like oceans in a hurricane. But what truly shocked scientists were the light curves. The fluctuations weren't random. They pulsed. They echoed like rhythmic breaths from an object that shouldn't breathe. Some researchers began to speculate. Were we witnessing something deeper? Perhaps the internal convulsions of matter not fully understood. Or worse, could these patterns mimic something else? Something that naturally resonates like a signal? What JWST captured wasn't just weather. It was a heartbeat. And If brown dwarfs can pulse like that, what else is out there, hidden in silence, waiting for us to look closely enough to hear it? Everyone forgot about Neptune. It's cold, it's distant, it's isolated. But when JWST turned its infrared gaze toward the icy giant, it uncovered something extraordinary. Its faint ring system, last photographed clearly over 30 years ago, appeared in brilliant detail, showing arcs of dust with names like freedom and equality. But even more baffling was what shone brightest in the image, not Neptune, but its moon, Triton. Triton gleamed like a beacon, reflecting more sunlight than any object in the solar system due to its nitrogen ice shell. But that reflectivity was only the beginning. Scientists now suspect that beneath Triton's frozen surface, there may be a subsurface ocean, potentially, warmed by internal gravitational interactions or leftover heat from an ancient collision. And what's more, Triton orbits backward, in retrograde. That orbit suggests it wasn't born with Neptune. It was captured, possibly from the Kuiper Belt, possibly from beyond. And if Triton is a captured world, actively geologically alive, with cryovolcanoes and subsurface liquid, then it may not just be a moon. It may be a message in ice, a remnant of something older than our solar system, hiding beneath a surface so reflective it dares us to look deeper. The final piece of the puzzle may not lie in the stars or galaxies, but in the shapes we see, the strange symmetry in jets, the coordinated orientations of galaxies, the hourglass shadows in nebulae, and of course, the literal question mark hanging in the sky. Scientists like to dismiss patterns. Pareidolia, they call it the brain's tendency to find faces or meaning in chaos. But JWST is not a human eye. It doesn't hallucinate. Its sensors are built to detect structure, to isolate wavelengths and read data free of interpretation. And still, it finds shape. It finds order. And now, whispers among the scientific community have begun to grow.